Good morning, this is Dr. Turner for Integrated Math 1. Today we're going to be looking at 9.5, which is going to cover the last two types of points of concurrency or triangle center. In 9.4 we looked at end center and circumcenter, which are of course available on the 9.4 video, but just to summarize, our circumcenter was formed by perpendicular bisectors, and by drawing that point we ended up with a point that was equidistant from the three vertices. That point can be inside, on, or outside the triangle, depending on if it is acute, right, or obtuse. Whereas the end center was formed by drawing all the angle bisectors, and that point was equidistant from the three sides. So those were our two types of triangle concurrency we covered in 9.4. 9.5 is going to be looking at two other types of center. 9.5 is looking at centroid and orthocenter. That's the new information, but in 9.5, you're also going to have a couple questions that are looking at all four, whether as a diagram or by definition, and being able to identify the point of concurrency based on what's given. So your centroid is formed by creating what are known as medians. And medians are lines that are formed from an angle to the midpoint on the opposite side. So these aren't going to look exactly like angle bisectors. They're not going to look exactly like perpendicular bisectors. So it is a little different. So let's take a scalene triangle here. And again, as always, we're kind of going roughly based on what the computer here is showing. But a median is drawn from the center to the angle opposite. So that line there would be a median. It's going from the midpoint on one side to the vertex on the opposite side. And we can draw similar line segments here, going roughly, again, from the vertex to the midpoint on the opposite side. And then doing the same thing here, going from the vertex to the midpoint on the opposite side. So that point that is formed is what's known as a centroid. Centroid's kind of interesting in that when you draw the centroid, going from each vertex to the midpoint on the opposite side, you end up with what is known as the either center of mass or center of gravity. So if you've ever seen one of those old-fashioned toys where you have let's say like an eagle and you can balance it on your finger, it's based on identifying the center of gravity or the center of mass. Now, you usually don't see those as a triangle, but if I were to cut out this triangle, that point is where I could balance it on, let's say, a pencil, and it would stay balanced because the weight is equally distributed in all directions. So that is your center of gravity or center of mass, and that is your centroid. The other type of triangle center is what's known as an orthocenter. Okay? Orthocenter is formed by drawing what are known as the altitudes. Now, just like circumcenter, which is the first that we covered, orthocenter is kind of unique because you could potentially end up with a point of concurrency that is not on the triangle itself, just like with circumcenter. So let's look once again at an example of a scalene triangle. Now, with I'll change this a little bit here. With your orthocenter, again, it can be a point that is not on the triangle. How a orthocenter is formed is by drawing the lines from each vertex to a perpendicular angle on a line that contains each of the side. So with your circumcenter, you were taking a perpendicular bisector. So you're sort of starting at the side and drawing a line that was perpendicular. With orthocenter, you're starting at the angle and you're going to draw a line that is, again, perpendicular to the opposite side. So, for instance, let's start with the obtuse angle. Going from the angle perpendicular to the opposite side, this would be the line that I'm drawing. But because I know that it could potentially be either inside or outside the triangle, I'm going to shift that a little bit. And then I'm going to do the same thing with the other two sides. Now, with the other two sides, when I do this, see if it'll work here. Oop, there we go. Okay. You're going to essentially have to extend some of your sides. So I'm going to extend this side here. So when I draw the altitude for the top angle, it is going from, again, the angle to a line that contains the opposite side. So this is forming a perpendicular line, and know that blue line there is not one of the sides of the triangle, but it contains the bottom side of the triangle. So that's how that is formed. And then I would do the same thing with the other angle, where I am drawing again, we'll extend this here a little bit. I am drawing a line from each angle to a side that contains the opposite side. So here is one drawing perpendicular to a line containing the opposite side, angle, drawing to a line containing the opposite side, and then I would need to do the same thing for this angle for a line that is containing the opposite side. So I would draw a line kind of extending past this side here, roughly, more or less. And so if I'm drawing a line perpendicular to that, going from this angle, I end up with a point where those three lines meet, and that is my orthocenter. So even though I had an obtuse scalene triangle, just like with circumcenter, that orthocenter potentially can end up somewhere outside of the triangle. For 9.5, you're asked to be able to define and identify which triangle center is shown. That's it for today, guys. If you have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.